Sui is a new, innovative crypto project which is super hyped and chilled by many. Some even call it a Solana Killer. Sui is a platform based on tech of DM cryptocurrency of Facebook/Meta, which was discontinued by Meta itself because of regulatory pressure. The Sui smart contracts platform is an environmental friendly, high throughput, low latency and scalable permissionless blockchain. But can it live up to the hype? Should you consider investing or better stay away? These are the questions which we will try to answer in today's deep dive into Sui. Keep in mind that this is not financial advice. I am just producing high quality crypto content. Making these videos take me a lot of time. If you want more reviews in the future, make sure to like and subscribe to keep me motivated. Sui is a decentralized, permissionless smart contract platform, as already mentioned. It uses the Move programming language. Move is an open source programming language for building smart contracts originally developed at Facebook for the DM blockchain. Move is designed for blockchains with strong inherent security and a more understandable programming model than a lot of the solutions on the market currently. Move is safe and expressive, and its type system and data model naturally support the parallel agreement/execution strategies that make Sui scalable. The Sui team has further developed and improved the original programming language so that it is even better optimized for today's blockchain needs. Sui's variant of Move and its object-centric data model make composable objects/NFTs possible. The original version doesn't work well with NFTs. It also finally makes mass market blockchain games possible. The blockchain-oriented Move programming language eases the developer experience as well. The Sui team is excellent. Musten's founding team was deeply involved in the design and implementation of many key parts of DM. The co-founder and CEO Evan Cheng led the Novi research. Co-founder and chief scientist George Danezis was working on DMBFT and Block STM and anything else system related. Sam Bakshier, the CTO, was the creator of Move. He also was the Move team lead and one of the 4 original DM maintainers. Co-founder/chief cryptographer Kostas was the cryptography team lead. These are just a few examples of the people working at Musten Lab to build Sui. The team is bigger than for most other projects, currently counting 66 people, many with very good qualifications and extensive knowledge in the relevant fields. Due to the former experience and work at DM, the team has a very good understanding of what DM does well and what it does not. In the fields where DM is not well suited to today's blockchain needs, the team made proper adjustments to change these shortcomings. DM was designed as a fairly restrictive permission system for settlement of on-chain payments. A lot of the research Evan's team and in particular George did at Facebook was on building more scalable versions of key blockchain components motivated by the limitations of DM. Prominent examples include FastPay, Narwhal, and BlockSTM. Mysten the company behind Sui, was started in late 2021, and the goal was to build a scalable layer 1 that could handle consumer-grade applications and traffic. Quickly, it became clear that this was not possible if building on Diem. So they went back to the drawing board and came up with a new data model that supports fast pay and low latency transactions for arbitrary move code with single writer objects, not just payments. Then they figured out how to integrate this setup with Narwhal and Tusk. Advantages of the Sui data model are: it lets them integrate move in a more expressive and convenient way. The Sui model is well suited for games and NFTs, which the Diem model is not. Another example of great design choices are human-readable signing requests. Human-readable signing requests address a massive attack vector present on many existing platforms, including ones using Diem-style move. Their users must blindly sign transactions without understanding what their effects are. Making the wallet experience less dangerous is a key step for mainstream adoption of crypto wallets. And Sui supports this goal by enabling human-readable signing requests. The Sui platform relies on objects as its main building block. Sui objects can present any type of digital asset, including fungible and non-fungible tokens. We will refer to actions on the Sui platform, such as object creation, deletion, mutation, or transfer, as transactions. The key components on Sui are: first, objects. Sui has programmable objects created and managed by Move packages, aka smart contracts. Second, transactions. All updates to the Sui ledger happen via a transaction. Third, validators. The Sui network is operated by a set of independent validators, each running its own instance of the Sui software on a separate machine. Sui is a distributed ledger that stores a collection of programmable objects, each with a globally unique ID. Every object is owned by a single address, and each address can own an arbitrary number of objects. The ledger is updated via a transaction sent by a particular address. A transaction can create, destroy, and write objects, as well as transfer them to other addresses. Sui validators agree on and execute transactions in parallel. Sui has a native token called Sui with a fixed supply. The supply is capped at 10 billion tokens. A share of Sui's total supply will be liquid at mainnet launch, with the remaining tokens vesting over the coming years or distributed as future staking rewards. Some will most likely also go to the Sui Foundation. That has not been disclosed yet, but from what I have seen, the foundation will be charged with a mission of furthering the Sui ecosystem, similar to foundations of other coins, like, for example, the Ethereum Foundation. The Sui token has three purposes. First, staking. Second, pay for gas fees. And third, governance. In the future, it might also get a fourth purpose in case Sui gets adoption and it's widely used. Sui could be used as a versatile and liquid asset for various applications, including the standard feature of money, a unit of account, a medium of exchange, or a store of value, and also for more complex functionality enabled by smart contracts. The Sui system uses a delegated proof of stake model as consensus mechanism. It is a DAG-based consensus with low latency and high throughput. DAG stands for Directed Acyclic Graph. On recent tests, the Sui team was able to achieve 120,000 transactions per second, or TPS. Sui's main economic novelty is its specific implementation of the proof-of-stake mechanism. Sui objects can encode any type of asset, including fungible and non-fungible tokens. Transactions on Sui take objects as inputs and deliver new objects as outputs. Sui processes and executes transactions using a causal ordering approach. If the objects in two transactions are independent, then it doesn't matter which transaction is processed first. Indeed, it will often be the case that some validators process one transaction first and some validators the other. This design lets Sui parallelize transactions processing of non-shared objects. This is why this blockchain scales very well. This is how Sui's operations work in detail. Processing a transaction on Sui requires two broad steps. First, a user cryptographically signs a transaction with their private key and sends it to the current Aptos validator set. Each validator validates the transaction and, in case of success, signs the transaction with their own private key and sends the signed transaction back. Second, once signatures of at least 2/3 of the validators by stake have been received, these responses are then collected to form a transaction certificate. This certificate is subsequently sent to the validators, who check its signatures and execute the transaction. Finality is achieved once a quorum of validators has executed the certificate. The main economic benefit of Sui's transaction flow is it can be parallelized, as already mentioned a few times. If two transactions are not independent but use shared objects, then it's more complex. Shared objects imply that not all transactions can be fully parallelized, and moreover, that validators must run a consensus protocol to agree on the current state of a shared object. In these cases, a degree of parallelization is still possible by noting that while shared objects create causal dependencies, different non-causally dependent shared objects can be parallelized still. Sui assumes that typical blockchain transactions are user-to-user transfers or asset manipulation and optimizes for that scenario. This design achieves very low latency by foregoing consensus for simple transactions involving only owned objects. In Sui, the consensus protocol is required only when the transactions involve shared objects. For this, Sui offers the Narwhal and Bullshark DAG-based mempool and efficient Byzantine fault tolerant, or short BFT, consensus. Narwhal and Bullshark represent, according to the Sui documentations, the latest variant of decades of work on multi-proposer high-throughput consensus algorithms. When shared objects are involved, the Sui validators play the role of a more active validator, comparably to the role of validators in other blockchains, to totally order the transactions with respect to other transactions accessing shared objects. Simple transactions are treated in a unique way. Many transactions do not have complex interdependencies with others. Often financial users just want to send an asset to a recipient, and the only data required to gauge whether this simple transaction is admissible is a fresh view of the sender's address. This observation allows Sui to forgo consensus and instead use simpler algorithms based on Byzantine consistent broadcast. Complex smart contracts may benefit from shared objects where more than one user can mutate those objects, following smart contract specific rules. In this case, Sui totally orders all transactions involving shared objects using a consensus protocol. Sui uses a novel peer-reviewed consensus protocol based on Naval. Then, Sui massively parallelizes execution and shards it across multiple machines. This is the secret of their scalability. They don't use a total order of transactions. Instead, casual ordering is done, allowing massively parallel execution. This is different to the sequential approach of traditional blockchains, where a mempool is used while the current block is under consideration. Increments to the chain are added one at a time, like pearls on a string, which often is the bottleneck on other systems. The downside of Sui's approach is that each address can only send one transaction at a time. This restriction doesn't exist on normal blockchains. Casually ordering transactions reduces latency and allows validators to take advantage of all their CPU cores. Sui also has a very sophisticated gas price mechanism. Sui's gas pricing should achieve the triple outcomes of delivering users with low predictable transaction fees, of incentivizing validators to optimize their transaction processing operations, and of preventing denial of service attacks. Since validators agree on a network-wide reference price at the start of each epoch, Sui users use the reference price as a credible anchor when submitting their transactions. Moreover, the price setting mechanism is designed to reward good validator behavior, thus aligning incentives between Sui token holders, the network's operators, the validators, and its users. How this mechanism exactly works is beyond the scope of this video. This mechanism is believed to deliver good user experience to Sui users who can focus on using the Sui network without worrying about having to forecast the current market price of gas fees and potentially overpaying for the fees. Another problem would be to underpay and not having your transaction processed or having a huge delay until it's finally picked up by the validators, which also is avoided by having a reference price. The gas price for processing a transaction persists of two parts: the computation fee plus the storage fee. Storage is also a huge topic in Sui. They even got a storage fund with the task to collect storage fees and pay validators for storing the relevant blockchain data. This fund is designed to last forever. It's not consuming its principal, only paying out the staking rewards from its Sui token reserves. Validators have two tasks. First is validating transaction. Second, they also have to store the relevant data, and this needs to be compensated too. Over time, the storage requirement increases immensely, and the storage fee and the fund are intended to ensure that validators can continue to perform their task in the future and are compensated accordingly. In other words, Sui's storage fund is used to shift stake rewards across time and compensate future validators for storage costs of previously stored on-chain data. The storage fund and the storage fee are way more sophisticated than this, but the before said is the gist of it. The protocol defines a base fee as explained before. It is algorithmically adjusted at epochs boundaries, and transaction senders can also include an optional tip. Under normal system load, transactions will be processed fast even with no tip. However, if the system is congested, transactions with a larger tip will be prioritized. Sui's gas price mechanism is intended to make the reference price a credible anchor for users to use when submitting transactions to the network, thereby providing reasonable confidence that transactions submitted with gas prices at or close to the reference price will be executed in a timely manner. In cases of extreme network congestion where validators cannot scale fast enough, the tips presents provides a market-based congestion price mechanism that discourages further demand spikes by increasing the cost of transacting on the Sui platform. Another special feature of Sui's proof of stake mechanism is that validators receive their share of the staking rewards at the end of each epoch with full certainty. They are not at the mercy of randomness like on other chains that make revenue easier to plan and removes the luck factor. Standard, however, is that validators are incentivized to participate in good faith via a share of transaction fees, staking rewards, and slashing to punish misbehavior. Within each epoch, operations are processed by a fixed set of validators, each with a specific amount of stake delegated from Sui holders. Staking Sui implies the Sui tokens are locked for the entire epoch. Sui token holders are free to unstake their Sui or to change their delegate validator when the epoch changes. The Sui economic model works as follows. At the beginning of each epoch, three things take place. First, Sui holders delegate their tokens to validators. Second, the reference gas prices are set in very complex mechanism called the Sui gas price mechanism. Third, the storage fund's size is adjusted using the previous epoch's inflow and outflows. During each epoch, users submit transactions to the Sui platform and validators process them. For each transaction, users pay the associated fees. At the end of each epoch, the protocol distributes stake rewards to participants of the proof of stake mechanism. The total amount of stake rewards is calculated as the sum of computation fees accrued throughout the epoch plus the epoch's staking reward. The later component is optional, in that it will be disappearing in the long run as the amount of Sui in circulation reaches its total supply. It will be used in the beginning to bootstrap network participation. After explaining this blockchain, let's now come to the downsides and potential disadvantages of the project. The design complexity is insanely high. That's why it's very hard to fully get behind the project's inner workings. The main white paper is very technical and hard to understand for a non-blockchain developer, maybe even for them. While traditional blockchains require implementing only a single consensus protocol, Sui requires two protocols. First, a protocol based on Byzantine consistent broadcast to handle simple transactions, and second, a consensus protocol to handle transactions with shared objects. This means the Sui team needs to maintain a much larger code base. Building an efficient synchronizer is harder in Sui than in traditional blockchains. The synchronizer sub-protocol allows validators to update each other by sharing data, and it allows slow validators to catch up. Building an efficient synchronizer for traditional blockchains is no easy task, but still simpler than in Sui. Sui forgoes consensus for many transactions to reduce their latency. The downside of allowing head-of-line blocking on the sender for these simple transactions is that the sender can send only one transaction at a time. As a result, it is imperative that the transaction finalize quickly. Sui will also face intense competition from other layer 1 blockchains. It is not only important to mention the long established ones such as Ethereum, Avalanche, Solana and many more. There are also several competitors who also program based on Move. The best known of these is Aptos. Move is closely related to the Rust programming language. So you can expect intense competition for software engineers with Aptos, Solana and Nia. Competitors that are already on the market have the advantage that there are already many building blocks on them and a network of useful apps already exist. This network effect and the adoption has not yet happened for Sui, and building an ecosystem has yet to succeed. Building on other blockchains does not mean starting from scratch. There are many users and other projects already existing on them. My biggest concern, though, is the high valuation Sui already is at. After Series B completed, Mysten Labs is now valued at $2 billion. $336 million were raised. Only VCs had the chance to participate yet. The venture capitalists investing read like the who is who of blockchain investors, including but not limited to FTX Ventures, Jump Crypto, Apollo, Binance Labs, Franklin Templeton, Coinbase Ventures, Circle Ventures, and many more. Such a huge interest of top venture capitalist firms shows that this is a very promising and interesting project. These VCs normally do a quite good job evaluating projects, and they only invest if there is a lot of potential. The bad thing though is that we normal guys didn't got a chance to participate yet. The valuation is already sky high, and once we can participate, we will most likely have to pay another huge premium, making it questionable if it's still worth to invest at multi-billion-dollar market caps. The concentration of coins and the original distribution of funds will also be terrible. A few venture capitalists, the foundation and the team will have almost all the tokens. That's not what we call a fair launch. Valuing projects at 2 billion already, which is not even in its mainnet, seems also quite excessive, especially given the intense competition from both existing and also coming projects. Let's come to the conclusion. There is not all information out there yet. Based on the information already available, I find this project very interesting, and I plan to constantly look out for upgrades and the final launch. Not sure if I will invest though once it comes available, as the valuation is already high and it might go up even more. The team is fantastic. I would grade it world class. I am not a software engineer though, so take this with a grain of salt. Overall, Sui is very well thought out. Examples are the gas price mechanism and the storage fund. It's designed to provide an economic mechanism that is viable in the long run. It's really trying to align the interests of users and validators. The design choices and the incentives put in place seem to put it ahead of its main competitor Aptos. I would also assume that the team of Sui is even better than the one of Aptos. It doesn't have to hide from other competitors like Solana either. The title Solana Killer therefore is not unjustified. However, we are only in the early stages of development, and it is still far from clear how the project will develop and if it can live up to the hype. I definitely worry about the lack of decentralization due to only a few VCs being invested yet. Tokens will be very concentrated in the hands of very few people. The key innovations which make Sui interesting is its data model and the transaction processing. Sui organizes data in objects. A NFT, a coin balance, a smart contract. Each is a distinct object. This allows smart contracts to express computation on objects. It also means transactions are naturally organized in groups based on the objects they are targeting. These groups can be processed independently and in parallel. Traditional blockchains choose total order on transactions then execute. No parallelization. Sui choose casual order on transactions then execute. Total ordering only required for transactions with shared objects. For transactions without shared objects, no need for consensus. Sui can scale horizontal. On Sui, each group of transactions is processed in parallel. Sui is a perfect fit for NFTs, but also works better in games than most other chains. Its programming language Move is superior to the often used Solidity, as it's more developer-friendly and more secure. But it also has the downside that it's not EVM compatible, meaning that apps on Ethereum need to be rewritten to port it over to Sui, which could be a barrier to entry, as first copy-paste of existing apps is not possible, and second, people need to learn a new programming language in order to program on Sui. Let me know what you think about Sui and if it is a Solana killer or just another shitcoin. Thanks for watching. Don't forget to like and subscribe. If you also want to learn about Aptos, watch this video next.